Hello, and thank you for tuning in to the Flatirons Syndicate Motorsports Podcast. This show is brought to you by Flatirons Tuning, your source for any aftermarket or OEM Subaru parts. Be sure to check out our store at flatirons.com and stay tuned with Flatirons Tuning. Well, welcome back, everybody. This is the Flatirons Syndicate Motorsports Podcast, episode number 87, believe it or not. And I'm here again with some guests, again from Race Comp Engineering. We've got Drew, and we've got a new face here, Larry, also from Race Comp Engineering. And the reason we're bringing you guys back on is I had kind of some email conversations with Drew and Miles about valving, and specifically a specific kind of valving, which apparently has become a little bit of a hot topic, which is called digressive valving. And it's something where it's maybe a little bit complicated. And I wanted to bring you guys on so we can actually talk about it. Drew, you actually were like, valving is actually pretty big. If we're going to talk about digressive valving and valving, we should just focus on valving. So that is what we're going to do, and I'm excited. Me too. This is going to be good because suspension is one of those things where it's a little bit of a, I don't know, if there's witchcraft involved in a car, it's probably going to be involved with the suspension. Like that's the easiest place where there's just like, there's some things going on that are just not transparent to a lot of us that are drivers. And the setup is just so key. When it's right, you know it's right, and the car just works. When it's wrong, oftentimes it can be something really difficult to figure out. And when it comes to actually like purchasing a suspension and then getting it put on your car and having a good place to start with it, you know, most of these coilover suspensions have some kind of adjustment for valving, but many of us do not know where to start and how to use that adjustment or what. And sometimes it can actually be hard to even figure out like what those clicks feel like what are you making a positive change or not. So that's what we're going to talk about today. So Great. With all of that laid out, where do you guys want to start? What do you think is the best entry point?
Well, I mean, I think like you said, coilovers and dampers and shocks, and suspension in general, like the more you learn, the more you learn that you need to learn. I guess it's kind of like a bottomless well. And I mean, I've been at Race Comp for good Lord, almost 20 years now, and wow. I'm still learning all the time. Sometimes getting real nerdy, but some different areas that are kind of like the aftermarket suspension world is advancing, and so there's things like simulations and modeling and different testing techniques that I think are really uncommon at like the Subaru aftermarket suspension world, but basically everyday stuff for the like real motorsports race teams.
Sure.
And that's stuff I'm getting more into. And you know, there's always something new and exciting to learn about. So yeah, I mean, and like you said, if you buy a shiny new coilover and it's got a knob or two or three knobs on it, where do you start? And I mean, the basics is really, in my opinion, the basics are enough to get most people in the right area. And a lot of times people just dive into, well, I need 3 clicks of compression to really get this corner right. And meanwhile, the rest of their suspension is completely terrible. Yeah. And focusing on, you know, the knobs is not always the best place to start.
Sure.
Yeah.
Well, and maybe a good entry point is just to talk about what the difference is between valving and the springs.
Yeah.
Because when you talk about valving, I cannot tell you the number of times that people have said, well, I want a coilover suspension because when I'm just driving on the street, I want it to be nice and soft and a really comfortable ride. And then when I go to the track, I'm just going to turn the knobs up so that I have a nice, really tight suspension. And that's just not how it works. I mean, I wish I could tell you that was how it works, but that is just not how it works. And I think maybe like the beginning of the disconnect is just an understanding of what valving does and what the job of the spring is and how the two relate.
Yeah. And so when we talk about spring rates, we're usually looking at like pounds per inch. That's usually how we measure a spring rate. And so that means it's for every inch you get a certain force. So it's a force per displacement, or how much it's compressing or extending.
Or basically 300 pounds per inch. It takes, if you put 300 pounds of weight on the spring, it's going to compress 1 inch. I mean, it is that straightforward.
Yeah. So they are a little bit more easy to understand. Still a whole nother thing. But let's say you get your springs right and you got the right perfect spring rates and stuff like that. It's when you look at dampers, instead of being like a force for every distance or displacement change, it's a force for a change in velocity. Mm-hmm. So it's sort of the same, but not. So whenever your shocks are moving is when you have this reactive force. And that's really key, because if you're trying to tune out like mid-corner understeer where the car is like set and it's taking a set and you're cornering and it's kind of a constant radius thing, your shocks might not be moving very much. So you maybe shouldn't be focusing on them, maybe. Mm-hmm. But that's a key difference, is that you get a force per unit velocity as opposed to a force per displacement.
And to add to that, I think most people don't realize that there are still two different types of springs, progressive and linear springs as well.
Sure.
Obviously, what we're talking about is a full linear spring of 300 pounds per inch.
Right.
And some coilovers still come with progressive springs on the front end. That ranges throughout how much is compressed. So
Well, and the other, I've actually got a visual aid here that I've just always had on my desk, but there's one other aspect of the springs that's important. This is my little bobblehead here, which is on a spring. but if you compress it, it bounces.
Yeah.
And that's the other thing with the spring, is that it's going to compress and store that energy, but then it's going to release that energy back. Yeah. That's the other thing I think that you have to have in your mind, especially when you're starting to talk about valving, is that spring is going to compress and then it's going to release that energy, and that's its normal behavior. And it doesn't just compress and then release; it does it in a cycle.
Right, and that's where dampers come in. So great segue.
Yeah.
So dampers. If you're driving behind a junky old car on the highway and it's just like bouncing and bouncing and bouncing, and it looks like the road's flat, and it's because it hit a bump half a mile back there. Right. Its dampers are blown, and the shocks are not on that car, are not doing the job of converting that oscillating motion into heat. That's what dampers do. They're converting motion into heat, and the way they do that is it's a tube or a twin tube, but we'll get into that later. And it's kind of like the one analogy I heard is like it's like a bike pump that is faulty. Right. So imagine like pushing a bike pump, but it's got some holes in the piston and some washers that let some fluid go. But you're basically pushing a disc with holes and some washers through oil. Through fluid, yeah. And so that is kind of moderating that motion. And hopefully returning things to a steady state, and so that the car is settled.
So the first question I have for both of you is why would you want to do that? Like we've all seen those old cars. In fact, I was driving home behind one yesterday where there was just like it was bouncing. And so I know that that's not good, but can you kind of quantify why that is? Like what is bad about that? What is that doing that you do not want?
Well, so I mean, it's not comfortable. It might make you throw up. Even just watching it sometimes makes you a little sick. But the idea is to minimize the load on the tire, how it's changing. If the load on the tire is going up and down and up and down, it's going to be really, really hard to control the car, because the tires they like a consistent load on them to generate grip. And if you can minimize how it's changing with a damper, that'll give you control. Keeping the car's body settled and controlled is easier to drive, and kind of keeping the forces on the tires consistent and predictable. And that's kind of like the basics. You can start doing some fancy things with it on how a car kind of enters a corner or exits a corner, based on how you're kind of distributing forces as things change, as the car rolls, and reacts to you turning the steering wheel and that kind of thing. But at most basic level, it's just kind of returning things to settled quicker, or at least in a way that's predictable, and keeping the tires in a comfortable place.
And then, obviously, like what Drew mentioned, the roll, pitch, and dive of a car, that's, you want the car controlled, and those main three things, that dampers, suspension helps that the most.
Yeah.
And that's what you in the driver's seat, you feel all of that. You feel all of that change. When people are saying my car has too much body roll, it's because you're feeling that the shift, the yaw of the car, you can feel that inconsistency, and that's not confidence inspiring.
Yeah. And that's one of the things that's tricky about dampers. In car suspensions in general, confidence counts for a lot, in terms, especially for the types of drivers that we are, which is to say, I'm not fast, and Larry can actually drive, but
not being fast.
But confidence counts for a lot, and then being able to approach a limit more quickly will make you a faster driver. Approaching it in a way where you actually are in control.
And consistency.
Count.
Yeah. And I think we talk, we don't, obviously, movement is good. We don't want to eliminate all of the movement, like, especially in, HB cars and street tires, cars with non-aero. You want some of that movement. You want to feel some of that body roll. And you want to know what the car is doing. Right. But at the same time, you don't want that over-exaggerate where it's too much roll and you can't figure out what the hell is going on with the car, or you come into a corner too hot and you're braking, but the car is going sideways everywhere.
Yeah.
So now let's talk about where does dampening and valving come into that in maybe like the very basic settings of what valving is and what it does.
Yeah. So let's say you got your springs perfect. You dialed in your spring rates, and you know exactly how stiff you want your main springs and your roll bars and all that. The goal after that is, so like we said before, if you ran a car without shocks and you hit a bump, the car will bounce and oscillate forever, other than friction. The rate at which it bounces is dependent on the springs. If it's a very stiff spring, it'll bounce really fast, and a soft spring will kind of do a bigger motion up and down. There's something called, if you're trying to choose how stiff you want your dampers to be, how much valving you want, there's something called critical damping. And so if that critical damping concept is basically how much valving you need to bring, after hitting a bump, bring the shock back to steady state without any overshoot. So shock goes up and then it comes back down without going down more and bouncing at all. And so critical damping is the least amount of damping you need to get back to steady state without overshoot. Any more than that, it'll still get back to steady state without overshooting. It'll just take longer because it kind of holds it up and brings it back more slowly. So some people call, 100% critically damped means critically damped. 150% means over damped. You have more damping than you need to bring it back to steady state. And then if you have less than that, but still not zero, you will come back to steady state, but it'll oscillate a little bit before settling. And it turns out that, in simulations or whatever, just running equations, a little bit less than 100% critically damped it'll overshoot, but it'll actually get back to steady state faster than 100% critically damped. So the numbers that get thrown around sometimes are like 65% or 70% critically damped. Those are ballpark numbers. And this sounds complicated and mathy and stuff like that, but it's not a lot of variables that you need to put in to figure these numbers out. There's calculators online, and you got to keep track of things like the motion ratio, and it does get a little bit nerdy. but
sure.
it's a target. And if you're in the position to really specify what type of damping you want, you could spend a little time and figure out how all that stuff works. Or you can talk to a suspension tuner and say, I want this, or these are numbers I hear are important. Should we do that? That type of thing.
Right.
But the idea is you want the car to return to a settled state quickly so that it's not oscillating too much and kind of extending a motion before it hits the next bump, for example, or with an overdamp scenario, we talked about how it doesn't overshoot, but it takes longer. So if you think about the shock compressing, but it hasn't returned yet before the next bump, it's already compressed when it hits the next bump. So that means your shock's already up, and then
you've already lost some of that compression travel.
Exactly. Yeah. And that's what we see a lot. A lot of people do run shocks that are way overdamped because it does kind of feel different. It reacts quickly. It kind of feels like what you think it's supposed to feel like, but it's not always faster. And especially on bumps, of which there are plenty around on the track, it's not necessarily the fastest.
Yeah, I think the most common thing we see is probably too low of ride height and overdamped coilovers. And those two combinations do not add up well.
Right. Well, that just is, there's this mentality out there that stiffer is better. The stiffer that your suspension feels, the better it is, the faster it is. And Drew, I just want to go back to your point about like the math and the setup. When we were last talking, one of the things we talked about is the difference between like higher level coilovers and lower level coilovers. And I think I just want to hit on this and then we can move on, but that development, that testing, that calculation that goes into the suspension, that's one of the biggest differences. One point I think that is worth making here is that it turns out there's a lot of different bumps out there. Yeah. That's one of the hardest things about this is that like you're driving on a track. I mean, there could be like a swell in the track or like a dip and a rough surface. I mean, you name it, there's almost an infinitely variable amount of bumps or impacts that your suspension is going to have to absorb. And you can't, like what we're talking about, an optimal scenario here, we're like, okay, I want to be, 60% critically damped. You could, if you know exactly what that bump that the suspension is going to have to absorb, you can build a suspension in that ballpark and it's going to work perfectly for that one bump. But then it's like, then there's all these other bumps that are just not going to play by those same rules. And then what you're kind of dealing with is a large average here, would you say?
Yeah. And so we both live in different parts of Baltimore City, and it's just awful roads everywhere. And
it's great testing roads.
It's
that's
nice. Nice.
Well, I mean, it's almost like so bad that we have to like reel it in a little bit. It's like, okay, if we perfect our car's suspension for like this road, we are going to be making compromises elsewhere. And so sometimes we have to be like, okay, this is just the same shitty stretch of road that it's been for 10 years, that's been under construction for my entire life. And like, it's not something that we want to optimize our suspension for, because we're not driving Ford Raptors. But, and then we'll go out to like the suburbs and still some kind of crappy stretches of highway. And like, okay, this is like, okay to kind of like get a test on ride quality. But still around town, like, drive on cobblestone a lot. And it's interesting how that works. There's a concept called like transmissibility. And like, so if you go over it at a certain speed, it can feel terrible because it's cobblestone, but sometimes you go a little bit faster and it smooths out and like things kind of hit like a resonance where everything's fine. And that's just like one, we're not optimizing our cars for cobblestone. But it's just interesting it gives us a range of like situations and kind of see how things feel. Sharp edged bumps versus kind of sloping bumps, and then the stretches where there's like bump after bump after bump, and that's a good test for if it's packing down, if you have too much rebound and it kind of hits and stays up. It's like these little bumps that like we know and can use for like certain scenarios.
Some didn't make rumble strips on on an exit curb on a track. It can be that rough sometimes, but okay. And so we were talking about critical damping, and and you brought us on to talk about digressive damping, and
I think you're getting at this a little bit in your last comment about so different types of bumps, and one setup isn't always the best for all sorts of situations, and that's true of digressive damping too. And I think sometimes people kind of see marketing that says super ultra mega digressive damping, and it's like, awesome, but more important than that is, are the forces actually good? Do they actually work with the spring rates and match the spring rates? Because you can have digressive shock, but if it's like super over damped, it's not going to be good. It's going to be worse than a linear damper that is not over damped, and actually that happens all the time. And actually, I mean, I think most modern Subarus from the factory use dampers that have some digressive aspects to them. I mean, BRZ dampers are a little bit digressive. The new WRX dampers are a little bit digressive. So it's not like a magic perfect shot.
And the important detail too is there are degrees. You have an adjustment knob that is going to control how the damping behaves, and if the damper is set up to be digressive, there are degrees of how digressive it is and how that behaves. It's not a yes or no question. It's like I want 60% critical damping, and what percentage of that do you want to be digressive, or what percentage of digressive damping do you want it to have? We're talking about a lot of gray areas, and that's there's so many gray areas, and that's where it becomes a lot more nuanced.
Right. And some shocks, I think they might not even get digressive until a certain point of adjustment. Between that, it might just be a progressive shock.
Yeah, that's something that we see frequently is, and that's okay, depending on how it's all built to work. If for certain lower grip situations, if you can have like a little bit of a progression at first, that's fine if that's what you want, and then turned up, it can be a little bit digressive. There becomes issues where, if you're turning the knob and you think it's doing one thing and it's doing something else completely different. But also B is something that we see is shocks that have a huge adjustment range. And what that looks like is, depending on how they're doing their adjustment, if it's primarily adjusting low speed damping with bleed, that ends up being a shock that is progressive for most of its adjustment range. And then when you get to the very stiff settings, it is digressive. But at that point, you're way too stiff to be using anything. I was looking at a very popular shock, coilover for BRZs that I'm not going to mention. But it's a digressive shock. But at full stiff, it's something like almost 600% critically damped. And so this is a coilover that was built to work with 7K front springs. And to be in that like 70% critically damped range, it would need like 5,000 pound spring springs or something like that. At full stiff. At full stiff. Right. So at the softer ends, it does sort of work, but it's not digressive at full soft. So
well, maybe a good place. This is a good place to define like what is a linear dampening, and then define what digressive dampening is. Like, so start with what like a progressive or linear dampening would be, and let's define what digressive dampening is or means.
If you had a linear damper, linear valving, the shock, regardless of the input, the velocity of the shock compressing or extending, you would stay at that same level of critical damping, no matter what. For every set increase in velocity, you have the same increase in force. So you see a shock dyno, which is force on one side on the y-axis and velocity on the x-axis. It just looks like a straight line, or a V, a sideways V. So yeah, same increase in force for every increase in in velocity, and that means that the critical damping ratio stays the same. So yeah, that's a linear damper. The damping ratio stays the same throughout the full range of velocities. And when we look at a progressive damper, is on a shock dyno, it'll look like the slope of the line increases, so it kind of curl up at the end as you go to the right, which means that low speed, which is so we talk about low speed and high speed with shocks. That means the speed of the damper compressing or extending, not necessarily the speed of the car, but the speed of the piston going in and out of the shock. So low speed is kind of small bumps and or body roll, pitch and dive, that kind of thing, more the handling side of things. And high speed being big bumps, curbs on the track, and jumps if you're into that.
Sure.
And so progressive shocks, they will have the damper force continually increases. It's still increasing as you go up, but the rate changes. So the slope of the line increases on the high speed end. So that means in the high speed end, as you increase damper velocity, you get more of an increase in force than you did on the low speed end.
Right.
And that does, sometimes it gets like kind of looked down on, but it does have some like actual applications for dirt and off-road and some rally.
Thinking about your Ford Raptor example there, you're going over some like, light bumps and so like that's low speed compression. And so like it's soft valving, so it can absorb those. Then you hit a speed bump or like, I don't know, another car. And then there's a fast impact. And so then the dampening will ramp up to prevent you from just like popping the strut top through the hood and try and absorb that impact.
Yeah. And I think people get it sometimes mixed up a little bit sometimes, and they forget that cars and trucks like the Ford Raptor, which is apparently, I've never ridden one, but apparently one of the best like riding vehicles on the market. And it's because it has tons of travel. And so you can run softer springs and then have some more damping on the high speed end, because you have soft springs and you have the travel, but you do need some damping to kind of keep it from bottoming and keep it from sending the spring through the shock tower.
Seen it happen, not on a Ford Raptor, on rally cars. But all right, so we've got linear, which is basically a 45-degree line. We've got progressive, which is basically ramping up as the impact increases. What is digressive? Let's talk about that.
The idea behind digressive valving is you want a shock to have more control in the low speed range, more force. Not more force, but a higher damping ratio. So there's actually still more force in the high speed range, but we're increasing it at a slower rate as velocity increases. That's another common misconception, I guess, is that there's less force in the high speed range than there is in the low speed range with the digressive shock, but that's not really true. It's just the slope of the line changes, and with that,
it's in a different place.
So
the low speed has, say, like rebound, will have more of a sharp knee. Right? So you'll see more of that line aggressively at first, and then it'll kind of taper off.
That's when the change in slope, when you see the line kind of turn, we call that a knee, and that's usually from like 2 to 3 or 4 inches per second, and that's kind of like the dividing line between low speed and high speed, or you can also say there's a mid speed too. I think that is useful. But so the idea is you want a good amount of damping in the low speed range to control like body roll and pitch and dive and that type of thing, and transitions and that kind of thing. You do want some solid damping there, but you want it to kind of blow off for bigger bumps and curbs, as long as you have the travel to do it. But you're usually, this is digressive valving was kind of the ideas behind it were kind of developed in line with like motorsports. And so we're usually talking about stiffer springs, not always. So it's kind of like, so you can take that curb, you can use the curbs at a track, without launching the car if you had the same damping ratio that you do in the low speed end. So basically, when you talk about critical damping ratios for a digressive shock, the goal might be 70% or 80% critically damped in the low speed range, and then less than that in the high speed range.
Right.
And that means that you have the increase in force per unit velocity changes after the knee, and it decreases after the knee.
Okay. So I'm thinking about your bicycle pump analogy, and let me see if I've got this right. So if we've got a linear valving and I'm pushing down on the bicycle pump, the resistance on me compressing the bicycle pump is going to be the same throughout the stroke of my pump into the tire. If it's progressive, it's going to get a little bit harder at the end. It's like there's going to be resistance at the end of the stroke, or if I'm pushing harder at the end, there's more resistance.
There you go. Yeah,
okay.
if you're pushing at the same speed, it's going to stay the same, regardless if it's linear or
okay.
progressive, or because remember it's kind of speed reactive.
Okay. So the faster I try and pump, the more resistance I will get with the progressive. Whereas if it's linear, I'm going to get more or less the same resistance, regardless of how fast I try.
Yeah, well, you will get more resistance. It's just that
the velocity is going to be
yeah. I mean, because remember, force is increasing no matter what for all of them. It's just that the rate of change is
different.
Yeah.
So and then with digressive, if I push faster, I'm going to get more resistance initially, and then it will kind of taper off to the bottom of the stroke. Or if I lift off at the end, it will taper off.
You'll still get more, but it won't be as much of an increase as it would be.
Right.
Yeah.
So what I'm thinking here is like, and maybe at this point we should also talk about like low speed versus high speed compressions, because so there's bumps, there's things that you hit, but then there's just the normal motion of the car. And thinking of it in a track driving circumstance, like, and I think this is basically what you're saying, but I'm trying to kind of clarify here. If you're just driving on the track, the normal movements of the car, like braking, accelerating, turning, that would kind of fall into that low speed compression zone. And then like you're talking about hitting a curb, like that's going to be your high speed compression. And what would happen if it ramped up?
Yeah.
So that's where the behaviors come in. Like what you're saying, I think from the digressive standpoint, or maybe what the rationale is, where it is said that this is what you want, is that you have a lot more control, stiffer valving in those normal, let's call them normal movements of the car, like braking, accelerating, and turning, just in that beginning motion of the car. So you're going to have a stiffer feel in those initial movements because of that type of valving.
Yeah, exactly. And I think that's part of what you're feeling with your Cuscos is they probably do have a good amount of low speed damping, and that does feel good and gives you control. And gives you that kind of like button down feeling.
Like they're great for autocross, right? Like something like that, low speed.
Yep.
And then the drawback to that is like, which is not that big a deal on track, is that some of those like very, very small bumps that kind of just move the shock a little bit, you'll start feeling those a little bit more with lots of low speed damping.
Right.
But like you said, on your card, some of the bigger bumps and impacts, you're not really feeling that much, or not as much as you would expect for the spring rates you're running, probably.
Right.
And that's where kind of that digressive taper off comes in. So and then and some of what you're feeling is probably also that it's a inverted high pressure gas shock with some gas pressure there. So there's a little bit of like an activation force, I guess you'd say.
Yes. And there's a lot of variables, like the type of damper, the oil that's in the strut is an effect, the valving there. And I think that there's so much minutia here. Like that's where it becomes confusing. Like when last we were talking, Drew, we were talking about the difference between twin tube and monotubes.
Yeah.
And like, the twin tubes, let me see if I've got this right. The twin tubes are better able to respond quickly. So they work well in that low speed compression zone. But then if you get into like a rough road, they are less able to deal with a lot of big inputs well. Whereas the monotubes, there's an inherent resistance with that strut to absorb those small inputs, and so like they feel stiffer for small, like for small low speed inputs. But then if you do hit something, or you take a large bump or something like that, that's what they do very well. And so there's like just those two different types of dampers have different characteristics. And then you talk about the valving, that also has different characteristics. And then like how the coilover is built, the type and weight of oil that is put into it, the pressure of the nitrogen, all of these things tip the scales in both of those directions as well.
Yeah, so I think that the other black magic is, obviously that's a whole other conversation too, is the actual pistons that you use, right? Mm-hmm. How big are the orifice holes in the pistons? How how many shim stacks are used between each one?
Yeah.
But that gets a whole.
And I think that's like for the advanced class.
That's a whole nother separate. Yeah.
And so I think for this, because we're trying to just talk about the concepts, like I think keeping it just focusing on the valving and not worrying about the type of the strut is the best, because that having a good concept of like where's this type of valving a benefit, where is it not a benefit, like is it really something that you want? Like I think that's where like having just a good handle on what is going on there, that's the biggest piece of information that I think is helpful to the most people. So they can see, okay, well this is what this manufacturer is telling me about this suspension, and this is what this manufacturer is telling me about this suspension. Does this really fit? Which A or B? Which one really fits with what I'm doing with the car, what I want the car to feel like?
Yeah, and I think the base concepts are really useful. I mean, no one's going to listen to this and be like, okay, I'm going to go build a shock right now.
Right.
But if they can, learn what to look for, or I think for me, one of the most important things is if you do have an adjustable shock, what does the adjustment do? Is it a rebound adjuster? Is it a rebound and compression adjuster? Is it affecting low speed? Is it affecting high speed? You don't have to crunch numbers or fire up your statistics software, but it can really help you if you do plan on turning the knobs. You got to know what they do. One thing that happens a lot is people will sometimes say they're bottoming out. They might turn their shocks all the way up to prevent bottoming out.
Full stiff.
To full stiff. But if your shock adjuster is affecting rebound, which is extension, it's going to have the opposite effect. It's going to keep your wheel up, and then it's not going to go up any slower. But then once it's up, it's going to stay up. So that means the next bump is
perfect.
Bad.
This is where so now let's clarify what these adjustment knobs are. So we have a spring, and there's compression, and there's rebound.
Yep.
And then in rebound, where the higher end coilovers, where they're three-way. Well, let's start with one-way. One-way adjustment typically is the rebound adjustment.
Correct. It's like typically rebound.
Vast majority. I know there are some struts that have like a knob that, like you said, Drew, adjusts compression and rebound.
Yeah.
But I believe that's pretty rare at this point. But can you just give a Cliff Notes version of how that would work?
Yeah. Typically it's rebound only if you have one knob. And some of them by design do rebound and compression at the same time. And some of them are primarily rebound, but there's a little bit of an effect on compression. And so usually there's like when you're turning the knob, it's kind of opening up another pathway for the fluid or oil to flow through. And if it's a rebound only adjuster, there's a check valve, which means the oil can only flow one way. And so when it's moving the other direction for compression, it's not letting any fluid through. And the idea is that rebound is something that, and I think there's actually advantages and disadvantages to both, to doing it compression and rebound together, or just rebound. Sometimes I wish someone made just a compression only adjuster, but it's a different topic. But anyway, yeah, the idea is that rebound is kind of sometimes it's more noticeable, I guess, in some ways, and it has maybe a little bit more of an effect on handling, at least a more noticeable effect. And it can be more important to match rebound with spring rate than compression. And that's the thought behind it. I think that's much more nuanced than that. But
I would kind of say if you had compression adjustment, it's easier to, I think it would be easier to get yourself in trouble with compression adjustment, especially if you're not, if you're just clicking knobs and you're not, if there's not a lot of thought behind the clicking versus rebound. And so I think that's why the majority of the coilovers out there at this point, if you have one-way adjustment, one knob, it's going to be the rebound adjustment, because you can still control the feel of the car, but you're not getting access to the compression behavior, which is where things can get weird.
Yeah, and if you're changing spring rates, that rebound knob will help you kind of match things a little bit better. Whereas compression, still important. Would be nice to have that control over that, but the rebound knob is more important if you're switching spring rates on the same shock.
Right. So, all right. So in terms of rebound adjustment, what would you feel, or what kind of talk through what you feel in the car if the rebound adjustment is right and if it's wrong? Like what would be the indicator?
Yeah, so I mean, we've both been playing with this a lot over the last couple of years. We've been working on a couple of different sets of coilovers and feeling what is felt on the track and on these terrible Baltimore City streets. So rebound is it's tricky because sometimes people end up overdamped with too much damping. And what I was mentioning before, returning to equilibrium or returning to a settled state.
So I'll try and use so like if it's you're compressing and then the spring has to, or the strut has to extend with the spring to get back up to absorb the next bump.
Yeah.
But if the rebound is over damped, you're only going to return maybe halfway, and then you've only got half your compression travel to absorb the next bump.
Yeah.
And you just can kind of work your way down to the point where you run out of all your travel, and then
you're bouncing around.
Yeah. And so that's the too much rebound damping side, is if it just takes too long to return.
You can pack the suspension down.
Yeah, packing down. And then too soft is the oscillating too many times, which can be really. I
was driving behind that guy going home from work last night, where it's just bouncy, like because there's just not enough resistance on that return travel, and so just the car feels bouncy.
Yeah, right. And there's that 70% or whatever 60% critically damped. There's like guideline numbers for sports car, race car, passenger car, luxury car, and it can get 0.2, 20% critically damped for some fancy luxury cars. Of course, that's more kind of like in the old days. They're a bit more advanced now, but with softer springs and like kind of like a longer frequency, like oscillations that aren't quite as sharp, it can kind of feel smooth to have oscillations that are like this instead of like this.
Right.
running really stiff springs and not a lot of damping feels really bad, and you'll see it. So
well, and like maybe the next level of this is when you go to the track, because when you're talking about rebound, weight transfer comes in here, because like the way that the rebound is going to behave, like you're going into a corner and you hit the brakes, the front suspension is compressing, there's weight transferring to the front tires. Mm-hmm. The rebound behavior is going to control, like, okay, you come off the brake, so now there's not this force sending weight to the front or compressing the front suspension. What does that liftoff feel like? So that's where the rebound comes into play on both ends. Mm-hmm. So like, okay, the rebound has happened. What's going to happen is the rear suspension compresses. What's going to happen is the front suspension releases, and you're going into this corner. There's a lot of nuance here, but maybe like, again, from a one-way adjustment standpoint, you're going into a corner, right? You're on the brakes, you come off the brakes, you're initiating turn in. if the rebound is set right, front and rear, what do you feel? And if the rebound is kind of wrong, what are some of the indicators that your rebound is set wrong, maybe on the front and on the rear?
Yeah, you're right. So primarily up to now, we've been talking about ride. So just, going in a straight line, hitting a bump, what happens? That's mostly what we've been talking about so far. But when we start turning, that's a whole nother thing, I guess. So one thing that I've kind of heard and taken to heart is a car with a poorly designed suspension, and in my opinion, especially dampers, poorly set up dampers will both understeer and oversteer. And that lack of grip, I guess, is kind of like when it's overly stiff. You kind of turn the steering wheel and maybe it turns in for like a split second really, really nicely. A lot of people are kind of obsessed with turning. But then it kind of doesn't really take a set the way you want it to, and kind of skates a little bit, or if you enter the corner wrong, the exit will be all screwed up, and you'll have some ugly oversteer. And so it's really important to think about the different phases of a corner. So entry, mid corner, exit, and even like braking and stuff too, and thinking about which corner is compressing and which corner is kind of lifting up a little bit. On a braking, the rear is coming up. Exiting, the front might want to pull up a little bit. And so you think about how more or less rebound damping can have an effect on those things. So remember the motion activated, I guess, or speed sensitive of the shock. So the right amount of rebound will still keep the tires on the ground, and you'll feel that, and you'll get some feedback about what they're doing, and they'll still have some grip. Yeah, I don't know.
So I was like, maybe like a good example I always think of is like at some point going to shoot in turn 5. I mean, if you're going fast, you're coming in there at 100 miles per hour, deep on the brakes, third gear. And that's at that point, you're really nosediving. And then suddenly, the suspension is fully settled up front. And at that point, I think when you have a perfect amount of rebound is when you can let off the brakes, turn the car in, and the car stays flat or relatively flat, depending on your driving style. You want the car neutral, right? Mm-hmm. Too much rebound, I would say you could experience the car skating, understeering forward. If that
on brake liftoff.
Correct. And then because that brake liftoff is very quick, right? You're off the brakes, and then you're immediately right back on the gas. And if too much rebound, I think you would just end up understeering, skating off the course. When you have that perfect rebound, I think is when the car really it just grips, right? Everything plays into motion. Your front and rear, depending on how you have the car set. I like mine with a little front rake, for that reason. And then all the weight is towards the front, and I can really turn in. But if say, I guess too little rebound, and you might be turning into that corner slower than you think you will be, or tracking out of that corner a little slower than you think you would be.
Yeah, and it depends on too much or too little in the front, or too much or too little in the rear. Too much all around. It's gonna think about what each corner is doing, and how the tire is or isn't in contact with the road. This is kind of not a track driving thing, but a rally car thing. I heard from like a pro drive engineer that on a typical gravel rally stage, the tire is in contact with the ground like something like 50% of the time, which is insane to think about because it doesn't look like it. But gravel's different. But even on track, they're not perfectly smooth, and there's like little variations that are trying to keep the tire from being in contact with the ground, and that's in addition to just body roll and that type of thing.
Right. Well, and to that same analogy, let's just talk about the rear real quick. If you have not enough rebound resistance in the back, you can actually get too much weight transfer too quickly to the front, and the rear end feels loose.
Right. Yeah, and then that's when you feel like you're going to lose it coming in hard on the
right.
brakes.
You brake, you lift off, you turn, and then the car just keeps on
Next
going.
thing you know, you're in a tank slapper trying to control the thing.
Yeah.
So I guess it's a good conversation and a good picture to paint, because like those are some of the criteria that, like, most coilovers are one way, and if you guys are going to the track and you're trying to sort this out, those are some of the behaviors to look for. What about making change? Okay, so you think let's say you've got 24-way adjustable coilover. So that there's 24 clicks. Where do you start? And if if you're going to make a change, so you go into the corner and okay, now I'm taking in what the behavior of the car is. I know where I've started, which I don't know where we've started, but we'll find out. And then if you're going to start to make clicks, how do you make clicks in that scenario?
Yeah, so we started off talking about strictly just ride at first, just kind of straight line hitting bumps. And in my opinion, that is the most important. I think if you don't have that sorted, the rest of it's going to be terrible. So you start out by just kind of having the car settle in a predictable way and feel controlled after hitting the bump. You need that. And then from there, you can kind of tweak things a little bit, a few clicks in each direction. But you have to remember, I keep saying this, but shocks are velocity dependent. So if you're trying to tune out mid-corner understeer, where the car's kind of settled, you might not want to look at your damper settings first. But on the other hand, if the car is pretty good mid-corner, but kind of loose on entry or exit or something like that, then you might start looking at your damper settings. And again, it depends, if it's a rebound only shock, on entry, you might want to look at your rear settings a little bit more. On exit, you might want to look at your front settings a little bit more, because your fronts are your rear. On an exit, your rear is mostly compressing, depending on what part of exit. I mean, some people break it up even farther, but it's kind of identifying the problem, where it occurs, and
where in the corner it occurs,
exactly.
and think about what the car is doing. Corner entry, the nose is loading up. Apex, it should be pretty neutral. Corner exit, it's probably going to be loaded to the rear. Right. So think about the condition that the car is in at the point in the corner where it's not doing what you want to do. And then think about, okay, would I go to the rear or the front, and would I go stiffer or softer to try and correct this behavior that I'm experiencing at that point?
Yeah, I think most people, and it's hard for, I guess, like the average person who's starting out to comprehend these things while they're driving, right? Yeah. But I think, like we tell most people, like we have baseline settings for people at the track. But say like other coilovers and stuff, I think a good base ground would be the middle. You don't want to start in the middle. Yep. You don't want to start off all the way low, or you don't want to start off all the way high either, because that just gets you nowhere. You have no idea how it's too unpredictable.
You're at an extreme. If you're at either end of the extremes, you can only go one direction, and so you don't know. Yeah, starting in the middle, you can go either way, and so you have both options equally, and so middle is a good.
And some people might experience, understeer and stuff like that, oversteer, but then other things come into play. Obviously, tire pressures, alignment, and once you get all that sorted, then you can really start looking at, okay, do I need to tighten up my rear sway bar? Do I need to loosen up, tighten up my front, or do I finally mess with the damper settings?
Yeah, and I think that's really important for if you feel like you need to make a big change. That usually means something else is wrong. And you kind of go back to the basics, like tire pressures and alignment and that type of thing. So if the car is like really off, you got to take a step back and kind of look at the whole system first and start with the basics first, like alignment and tire pressures.
Well, and there's another big one that hasn't been mentioned yet: driving style. You as the driver, this is where the black magic gets really nasty. Is you as the driver have huge control over how these systems are going to behave. Like, and this is where, and this is why, like, Larry, you have your car set up. I could get in it and I could hate it. Drew might love it. Maybe you guys have really similar driving styles, and it works for you. I get in there and I'm like, this thing is like a milk truck. I don't know what you're doing out here. And then I change your knobs and I get it set up right. And then you hop it in and you're like, what'd you do to my car? You just turned my STI into a milk truck. What is going on here? And it's because there's so much difference or you have so much control with your driving input to how the suspension is going to behave.
Yeah, there's a lot of stories about motorsports engineers, and one for this, I think this is the Ford rally team in like the mid 2000s, and this is being told by a driver, and I forget the details, but basically a new team came in, same car, and basically changed everything. Went a lot softer on spring rates. Softer on shocks as well. And the driver telling the story loved it, and he was a little bit faster. And the other driver on the team hated it and was slower. And there's these like baseline guidelines and stuff like that, and you can run simulations and optimize things in a certain way. And I think you should. I think that's really important. But then the driver needs to be comfortable and confident. And
this is comfort. Like comfort and confidence is such a big part as a driver for getting the car to perform. And so that's you can never discount that. And I just wanted to hit that home, because you have to, if you're putting on a new suspension, you have to go in kind of with a blank slate, and you have to just drive the car and experience it and decide for yourself. Like, you can get some input, certainly. And if you're working with a good suspension manufacturer, something like RC, you guys have done a lot of testing, and you can probably talk to a guy. Like one of the things that's always telling is, with somebody with an STI is, all right, I need suspension. I need to change the suspension because my car doesn't work. And you start talking about, okay, well, where doesn't it work? Is the turn in the issue? Are you having issues at exit? Is it everywhere? And that lets you kind of hone in on the driving style of the person. And then you can kind of get a sense for like, okay, you need to try this starting setup versus this starting setup, because it's going to, that should get you in the ballpark of more close to what you want the car to do within reason.
Absolutely.
There's no miracles here, but
one other thing, it's kind of minute, but what I've seen is that a lot of mainly STI drivers like, I want to get their car to rotate more in the rear.
Yeah.
And I tell them, you can do that in the stock car. You turn the traction off, and the car really does rotate well once you have all the aids off. It really does perform. That you can feel the rear kick out, and you can really, when you feel it, you can kick out, get back on the gas, and let it settle and ride it out. Traction off, coupled with good suspension, tires, alignment. You're really set for a track day.
Yeah. Well, and then what's ironic is, to a certain extent, it might actually be better if the car doesn't rotate.
Yeah.
So what's funny is, well, and we haven't even talked about compression here, and I want to touch on it. We've already taken up an hour of you guys' time, so thank you very much. But I got to keep it a little bit longer. We got to talk about compression a little bit. But so with one of the guys we sponsor, Tasso, he's testing out a rally suspension for us on his rally car, and he put it on, and his initial response was, "I don't like it." And the reason he said he didn't like it, or he wasn't happy with it, is because he couldn't get the car to break loose. And he said he had to be really aggressive with his brake or throttle inputs to get the car to break loose to initiate a slide. And in a rally car, sliding is that's how you take a corner. You need to be able to do that. And so he didn't like it initially because of that. And fortunately, we're talking with an engineer at Cusco about this, and he's like, that's actually a good thing. Yeah. That in your scenario, that's actually a good thing, because what that means is that the car is more stable. And you have to really be aggressive with the brake or the throttle input to get it to break loose, but the car is more stable, so you can actually carry a lot more speed into the corner because you actually have more traction. And then you can get up to the limit of traction at a higher speed, and then you can control the car in that slide. And so he made a couple adjustments, went out there and matched his personal best at the first race that he ran with it.
That's awesome.
So it's one of these things where even if you think it's bad initially, you almost kind of have to go for a whole day. Don't touch any of the knobs, just drive the car for a whole day.
Yeah.
Pay attention
to rewire the brain, right?
Yeah. Pay attention to what you're doing with the car. Drive if it's not working the way that you expect, try a different approach. Try a different brake or throttle input on corner entry or corner exit to see if all of a sudden now it's behaving differently because it's doing something maybe better that now you can take advantage of that you couldn't before.
That's a super interesting topic to me, which I'm not great at, but the driver engineer conversation is just fascinating to me, and trying to interpret what the driver's feeling, and making changes that make them comfortable, but also make the car faster, and like kind of finding that balance. And we're talking about people sometimes expect a lot of rebound damping and sometimes too much rebound damping because it kind of feels like what they think it should feel like. But in reality, softer is oftentimes faster, but it sometimes does take a little bit of brain rewiring to be comfortable in that. Because it sometimes feels it moves around a little bit more than people expect. So
yeah, it's a balance. And this is the black magic. There's so many things at play here, and you can't discount that because there's no one silver bullet. Like just playing around with the suspension dampening. I mean, it could be an issue with your sway bars. It could be an issue with your bushings. It could be an issue with your alignment settings. It could be an issue with all of them. Yeah. Plus how you're using the car. And so that's where you've got to narrow down the variables and make small changes and get a sense of, like, I think one of the key first points is to get to the point where you can make a change and feel the change and know, okay, I'm going in the right direction or the wrong direction.
Yeah, make one change at a time. Yeah, and take notes.
Yes, and take notes
all the time.
I keep saying I need to get like a logbook of like the setup and just the changes that are made and like the conditions of the car, because like so many times when you go to an event, it's just you're in the churn of it and you're just like it's not doing this, so let's change the front brake pads and I'm gonna click some of the rear dampeners, and is it better now? It's better. Okay, just drive it, and then you get to the end of the event, and you're like, I cannot remember what I did. I know I did something.
Did I do the rear or front click shit?
Yeah,
I don't know. You got to go back and you got to figure it out. Like,
and like jot down, even if it's not that important, just a good practice. Like jot down the temperature, jot down like how you were feeling that day. Like I had way too much caffeine, and like that might have been impacting what I was feeling, and or I was up all night and I felt like crap, and so then the car felt like crap, and maybe it was me. And take all sorts of notes you don't think you need, because they can be important.
Paint that picture so you can get yourself back in that mindset of where you were at in the car and what the car was doing, and hopefully you can kind of suss out where you want to look at what might have been causing that issue. Cool. Well, guys, thank you so much for your time. Really appreciate it. Always bring you guys on. It's a good conversation. Really enjoyed it. And to everybody that's listened, hopefully this was helpful and informational and you enjoyed it. Thanks for your support as always. And until next time, stay tuned with Flatirons Tuning.
See you guys. Thank you.
Thanks everyone for tuning in to the Flatirons Syndicate Motorsports Podcast. Once again, we'd like to let you know that your support is what makes this show possible. Be sure to check out our online store at flatirons.com for any of your aftermarket or OEM Subaru parts needs. And as always, stay tuned with Flatirons Tuning.